Most organizations have already started their public cloud journey somehow. 38% of all workloads are currently running in public clouds, and this is expected to increase in the upcoming years. Increased agility and a broad variety of services, which can be deployed after a single click, are some of the reasons why public clouds have become so popular. This allows organizations to innovate faster and reduce infrastructure maintenance. However, it often involves changing purchasing models from upfront investments to on-demand, where planning budgets based on capacity and usage is part of a complete set of operational changes. While most of this automated and on-demand infrastructure could also be enabled on a private cloud, the public cloud offers a turnkey solution that is ready to be used at scale immediately. Migrating to the cloud may mean lift and shift for some organizations, or result in re-platforming or re-architecting applications for many others, with the latter resulting in more efficient usage of some cloud-native services. In any case, the time it takes to learn the cloud terminology, integrate a hybrid cloud model, and deliver security consistently are common concerns for CIOs, which have a direct impact on operations, time to value, uptime, and many others. With this in mind, let's start by understanding what changes in the public cloud, how it compares to on-premises data centers, and some key terminology you need to understand as a network engineer before we move into Cloud ACI and the reason for its existence. First, let's talk about availability. Today, you have to take into consideration multiple things to keep the business operational 24/7 when running on-premises. We usually include high availability and redundancy at the element level for switches, servers, storage, hypervisors, and so on. Then, we may provide different rooms, ACI pods, or even data centers to increase availability within a geographical area. And finally, we have to consider the risk of fires, hurricanes, earthquakes, and many others. Therefore, including multiple data center sites across separate geographical areas has been a common practice. Now, if we take a look at the public cloud side, infrastructure level HA and redundancy are fully managed by the cloud provider. You still need to consider redundancy as part of your overall cloud design in different levels. Cloud providers have regions and availability zones to support this. Availability zones are logical data centers with separate power and networking resources, which can help minimizing disruption in a specific region. Still, just like with on-prem designs, natural disasters may happen. Therefore, you want to make sure that you also consider multiple regions as part of your overall plan. There are multiple regions available in each cloud provider. Once you pick your cloud, you can choose the region where you want to work on. In the case of AWS, for example, you can see on which region you're working on in the top right-hand side of the Amazon console. Just like on-prem, you also need to have a way to monitor all your cloud resources by using cloud-native monitoring services, which usually come at an additional cost, or by implementing your own. Now, in our on-premises environment, we mainly have infrastructure, with services such as networking, compute, storage, hypervisors, and backup. Then, we have platforms running on top of that infrastructure, including the operating system, middleware, databases, and many others. And last, we also have applications, which may include multiple sets of software, services, and more. This is very similar in the public cloud. In terms of infrastructure, all the switches, storage, servers, and hypervisor are all managed by the cloud provider. So there's no need to patch, cable, or maintain anything. However, you still have to configure how you want to use such infrastructure. For example, choosing the operating system to install, the database you want to use, or the network and storage settings you may want. The only piece of infrastructure we do not need to worry about is the hypervisor, since it is entirely managed and configured by the cloud provider. Having network, compute, and storage configured and consumed this way is what we commonly know as Infrastructure as a Service, or IaaS. Then, there's another option called Platform as a Service, or PaaS. This may be helpful if you do not want to manage nor maintain the operating system, database software, or other types of tools and platforms on top of the cloud infrastructure. Cloud providers offer multiple PaaS managed services, which may include RDS from AWS and Azure SQL for database purposes, and many others. Concepts like Container as a Service, or CaaS, and Function as a Service, or FaaS, can also be considered PaaS offerings. When talking about CaaS, and when Kubernetes is the desired container orchestration system, cloud providers offer Kubernetes as a managed service. Kubernetes-based CAS offerings include EKS, AKS, and GKE from AWS, Azure, and Google respectively. Function as a Service is a type of serverless offering that allows organizations to directly run code on a cloud provider without worrying about the underlying CPU, memory, and operating system. Instead of paying for a VM along with its resources to run their code, customers using FAS are typically charged for millions of function executions and per gigabyte allocated to a function every second. Finally, cloud service providers may also offer software as a service or SaaS, where you simply consume the solution without worrying for anything else. There are multiple companies offering SaaS services today, including Cisco with solutions like WebEx, Intrasite, and many more. You should be very familiar with SaaS, especially through email. As you can see, there are multiple cloud-native services offered by each cloud provider through their catalog, and the list keeps growing every day. Making the most out of these services is one of the most important benefits of the public cloud, since building a similar list of services in a private cloud could take a long time. It's now time for us to take a deeper look into cloud infrastructure. Please join me in the second part of this chapter, where we will cover a few concepts on cloud networking, compute, and storage.